Hi everybody and welcome to Unit 2. So today we will begin with the first lesson, Level 1 or Mission 1 folder. Oops, sorry about that. Mission 1 folder of Unit 2. So Unit 2 is about simplifying expressions and solving linear equations. In this unit, we will have 5 different missions. Once you open Schoology, you will see that we will go in order to each one of those. So, mission 1 for this unit is apply order of operations. So go ahead and write down the topic, apply order of operations. As usual, on the left side you will see the packet for this mission, worksheet 2.5a, 2.5b, and 2.5c. All the worksheets will be under that mission. Now, here's an example of having different terms as one expression. So notice we have variable, we have a number variable, and another number. All of those things combined together we call expressions. But also each one of those has their own name. So each individual number or number variable here, like this one, this one, this one, this one, or this one, we call terms. So parts being added or subtracted from each other, we call those parts terms. So that will be the first vocab word for this mission. Second vocab word is like terms. With identical variable, parts are constants. So like terms will be the ones that have the same variable. For example, y and negative 3y are like terms. Also, if we have just numbers like 9 and negative 17, those are what we call like terms, and those will be just numbers. If I have 2h here and another term 5h, this will be another combination of like terms. Next vocab word is a coefficient. Coefficient is the number in front of the variable. So, if you look at carefully, for the first one, there is no number. If there is no number, it means 1 stays in front of the variable. So we have coefficient. I'm sorry about that. So go ahead and write down, finish your notes. Okay, so coefficient again is the number in front of the variable. We have coefficient of 1 here. 9 is not coefficient because it doesn't have variable. Then we have negative 3 coefficient, positive 2 coefficient. And the final thing is what we call constants. So now numbers without variables, only numbers, are those that we call constants. So 9 and negative 17 will be the constant number of this expression. Awesome. So once you know how do we call all those parts of the expression, we can go ahead and start combining like terms, simplifying. This is all part of order of operation. So first two examples, we're going to simplify these expressions. We have 2x minus 4b plus x minus 7b. Now, I'm gonna circle the two that could be combined because they're like terms. 2x plus x. And again, we said if there is no number in front of the variable, it means 1. So basically we have 2x plus 1x, that is going to give me 3x. Then I have negative 4b and negative 7b. We will combine those two because they both have b variable. So negative 4 minus 7. Remember the integers when we're adding or subtracting. Negative 4 and negative 7 will give us negative 11b. Now, we will try to simplify as much as we can. So let's see if we can do something here. 3x minus 11b. Now those two, they have different variables. We can't combine them. so that will be the final answer here. If we can't combine variables because they're different, then this will be the most simplest form that we can deal with. Great, let's take a look at the next example. 8g minus g plus g minus negative 2g plus 7. So, first thing, I'm going to put number 1 in front of those variables because I need to remember that 1 stays there. And let's go ahead and see what we can combine. So we have 8g minus 1g plus 1g. There is 2 negatives here that needs to change to plus, and plus 7. So that will be another like term. Let's rewrite this. 8g minus 1g plus 1g plus 2g plus 7. Okay, so since all of those are like terms, we will combine those. 8 minus 1 is 7, plus 1, 8, plus 2, 10. So combining all those, we get 10 g's. And then we're gonna just copy down plus 7. Do you think that will be the final answer? Yes, that will be the final answer because 7 doesn't have g. We can't combine those, so we are done. Alright, so you guys notice already I'm doing this recording at school and we have some distractions once in a while, so please ignore the announcements. And if I pause, go ahead and just pause the video if you want to and finish your writing notes and then play it again. You have the power to control the video. Example number 2. So this is another area of this lesson. Find the area of the rectangle. Sometimes we deal with adding integers and combining like terms, but sometimes we will have given those geometric shapes and we will be asked simple questions of finding the area. So we know the area formula for rectangular shape is A equals length times the width. So in this case, this whole part over here is L, the length, and this part over here will be the width. So the total area will be equal to length, which is x plus 4, times 3. And you can multiply times 3 up front. So we have 3 times x plus 4 inside the parentheses. Now make sure you have this inside the parentheses because this is one whole thing, so we want to keep those together, x plus 4, that's why we're using parentheses. And once you set up the problem, we will leave it like that at this point. When we are applying order of operations, also sometimes we're using distributive property. And you've learned distributive property in 7th grade pretty good, and I'm sorry. Alright, I'm sorry about that. So the area will be equal to 3 times x plus 4. Distributive property, to remind you because we need to simplify that, is we will multiply 3 times x and then we will multiply 3 times 4. Do you remember now? Distributive property, when you distribute the number outside to each one of the terms inside the parentheses. So the area here will be equal to 3 times x is 3x, and then 3 times 4 will be plus 12. That will be my final answer. We don't know what x is equal to, so we can't find the exact area, but this is how we simplify the expression in order to calculate the area. Very similar example to the first one. So again, we have the length here, and this will be the width of the shape. So the area is equal to, the width is 6x, and then times, inside the parentheses now, we're going to put x plus 7. That will be the simplification form. Definitely we can apply distributive property to simplify a little bit more. So the area here will be equal to, if you multiply 6x times x, we have 6 x times x is x squared. And then we multiply 6x times 7. 6 times 7 will give us 42. We have one x, and we're going to bring this x down here. When you have variable x squared and another variable just x, those two are not like terms because they don't have the same power. So we can't add the numbers, we can't combine those. This will be the final answer for this expression. Alright, well, let's take a look. What else do we have from this lesson? So now we have an application of distributive property. When we apply and practicing applying distributive property, I want you to write down the problem and have those boxes. So those are the boxes when we will use to put the answers inside. So go ahead and write down, simplify the expression, use distributive property. And the example says, for y, sorry again, so we have 4y times y plus 3 inside the parentheses. With distributive property, we will combine those two. And we said 4 times 1y will give us 4. Y times y is y squared. When we multiply two variables, we get square. Then we will multiply 4y times 3. So 4 times 3 is 12. We have one y here, we keep that. And because 12 is a positive, make sure you have this plus 12. So we simplify, or we apply the distributive property, and we get 4y squared plus 12y, final answer. Next example, sometimes you will have given inside the parentheses x minus 7 times negative 10, number negative 10. So with this one, we were going from left to right. With this one, we're going to go from right to left because we want to multiply this number with each one of the terms inside the parentheses. So negative 10 times negative 7 will give us positive 70, and negative 10 times x will give us minus 10x. And that will be the final answer here. Next example, we have a few things in a row. So we have negative 4 times inside the parentheses 2x minus 11 plus 5x. For this part, we're going to use distributive property. And let's start simplifying. Negative 4 times 2x will be negative 8x. Negative 4 times negative 11 will be plus 44. Negative 4, there is no another variable, so we don't multiply negative 4 with the number outside of the parentheses. We're done with distributive property. What we're going to do, we just need to drop this term and write it down here, plus 5x. So what we have, I'm sorry, so we have negative 8x plus 44 plus 5x, and we want to combine those. The two like terms here will be negative 8x plus 5x. Well, negative 8 plus 5 will give us negative 3x, and then we just copy plus 44. So final answer for this particular example will be negative 3x plus 44. Now let's take a look at this one. 7x minus absolute, not absolute value. Let's start again. 7x minus inside the parentheses 4 minus 2x. Now, 7x is the first term. We're going to just drop this down. But now you're wondering what's going on. There is no number here that needs to be distributed to 4 and 2x. So if there is no number, just like when we talk about variables, I want you to put 1, because 1 times this will be exactly the same thing. So basically you don't see 1, but 1 stays there. So now we have negative 1 times 4, which is negative 4. And then we have negative 1 times negative 2x. Negative 1 times negative 2 is just positive 2. And we write down x. There is one variable, we bring this variable down here. We look every single box and we see that 7x and 2x are two like terms. So 7x plus 2x will give us 9x and then minus 4. And that will be the final answer. Great. So if you need to pause, please pause, review, redo the examples. I have a few more to go and I will keep going. So if you think it's too fast or whatever, pause the video. If not, follow me. Alright, so for examples, to complete this lesson, we have 4x minus 7x minus 8. Well, again, in front of this parenthesis, I will just write down number 1 to remind me about the distributive property. So, I will write 4x, then we'll distribute negative 1 times 7x, which is negative 7x, and then negative 1 times negative 8, which is plus 8. Once I simplify with the distributive property, next step will be combining like terms. 4x minus 7x are the 2, and the answer here is negative 3x plus 8. That will be the final answer for this example. Next one, we have negative 6 times 5 and negative 6 times x. Negative 6 times 5 is negative 30, and negative 6 times x will be negative 6x, and then just plus 13x. Like terms again will be negative 6 plus 13x. So I'm going to write down negative 30, and negative 6 plus 13 will give me plus 7x. Final answer. Definitely at this point, if you are still not sure how to solve integers, even though they're small numbers, I would say you can go ahead and start using the calculator. That will help you to move quickly, and our main focus is applying distributive property and simplifying. So I'm not checking for adding numbers, I'm checking if you understand how to do correctly the process of solving and simplifying those expressions. Next example is 10 plus 5x minus negative 6. First thing, once you see those negatives, please change them to positive right away so we don't forget, and rewrite the expression. So 10 plus 5x, this will be plus 6. Two like terms here will be 10 and 6. 10 plus 6 is 16, and then plus 5x. Final answer, 16 plus 5x. Last example for today, we have 9c plus negative 4c plus 11 plus 6c minus negative 5. So those two negatives change to plus and rewrite everything. So we have 9c plus negative 4c plus 11 plus 6c plus 5. Now 9c minus 4c plus 6c are the three like terms. Let's calculate those. 9 minus 4 is 5, plus 6 will give us 11c. Then we have 11 plus 5, another combination of like terms. 11 plus 5 will be plus 16. And we got the final answer. Well, thank you for watching the video. Let me know if you have questions. We will have some discussions in class and as well on Schoology. So if you would like to be part of this discussion board that is going on, please make sure you post your questions so we can solve them. Thank you again and have a great day.